Hi, I am Patti Howell, and I'm recording this meeting because when I presented earlier, my recording didn't work. I did the meeting through a different email. So this is a recording of what I did, and hopefully it will come out a little bit better than the actual meeting. So okay. My name is Patti Howell, and you are watching Teaching Evolution in a Digital Classroom. What I want to show you tonight is what is ties, what are we about, why is it important to teach evolution, what resources are available. The resources that we have, a lot of them are digitized, a lot of them are self-paced. I'm going to show you some of my favorite things. I do not have a whole lot of time, so I will be flipping through stuff very quickly. I'm also going to end it up with how can you get more help and how can you get involved with our organization if you'd like. So a little bit about myself. My name is Patti Howell. I am a teacher in Southwest Georgia at Baconton Community Charter School. I've got my email address on here. Please feel free to email me. I have been teaching for about 20 years. I primarily have been a physics and chemistry teacher, and I felt very, very comfortable with those things. When I moved to this school a few years ago, I was the biology teacher. So I thought, oh no. Now, what's funny about this is that I happen to look really, really good on paper in terms of biology because my master's says MED in secondary education / biology. But it's totally not true. I look good on paper, but I had no clue. Most of my master's classes were in, chemistry, physics, stuff like that. I did not know anything about evolution. To give my age away, I am 53, so whenever I went to high school, I don't even know if they talked about evolution at that point. So as a biology teacher, I wanted to do a good job with what I was teaching, as good as I could, and I had to reach out for help. So I went to a workshop by TIES, Teachers Institute for Evolutionary Science. Our director, Bertha Vasquez, started this organization, and we are helped with the organization through the Center for Inquiry. Now, this is a picture of Bertha, our TIES director, with a Siberian fox. If you don't know what a Siberian fox is, I have an opportunity for you to learn about it, and I promise you, you will love the story. I have never met a person or a student who does not love the story about the Siberian foxes. So you absolutely have to get that link and look into it. You will enjoy it. So when I started teaching biology a few years ago, I can handle the molecular biology. I know about cells. So I'm thinking evolution. Why in the world do I have to really know about evolution? What's so important about it? Well, for those of us who care, I guess, it is in the standards. So as early as 6th grade, we start talking about plate tectonics and fossils and how the Earth's surface has changed. It is actually mentioned in our 7th grade standards. And then in high school biology, we have a whole big standard that is about evolution. Evolution is also written into the other standards that we have. So since it's in our standards, this is a tested course. We have a milestone, and it is close to about a third of that milestone is about evolution. It's a huge part. I'm not sure exactly how many questions, but it's a big part of our milestones. So that's important, knowing that the kids are judged on their understanding of evolution, and knowing that our livelihood is judged on their understanding of evolution. But here's the big thing, the really big important thing. Evolution is the primary organizing principle of life science. And when I started teaching biology from a perspective of evolution, it changed the way I saw things entirely. So I was completely just excited over what I was learning and how my teaching was changing. And so I got involved with TIES instead of just using their resources. I became a presenter for them, and it has changed very much how I view my role in the classroom, my interaction with the kids. It's just, I'm so excited about it. So I'm so glad that I did this. Now, so if those two reasons weren't good enough, another important reason to teach evolution is that it is in position statements of our major science organizations. For example, NSTA is in its position statement, it agrees that evolution is a major unifying concept and should be emphasized. It also references other major organizations like the National Academies of Science and AAAS, which is the American Association for the Advancement of Science. So I'm going very quickly here because we have so many resources and I'm trying to fit it into the allotted amount of time. I'm going to take you to the TIES website, which is this tieseducation.org. And one of the things that TIES believes is that if people understand evolution, they're more likely to accept it. So what they have done, they have provided people all over the United States that are able to help you. We can do quick workshops like this whenever we present for GSTA or whatever state that we're presenting for. We can do day-long workshops, half-day-long workshops, week-long workshops. We can do whatever you want. We just need you to contact us and we will help you out. Sometimes you just need an email or you need a phone call and to help you understand a concept. That is okay. We're here for you, and we've got people all over that can do that and point you in the right direction. Now, our website is right here, and I'm going to make sure that I have this for you. But we have found ourselves in this pandemic just kind of thrown into this different way of teaching. And so our people at TIES got really active in making guided lessons available for you. So if you are at a school that requires you to have like a 2-week lesson plan in case you can't come in because you're too sick or something like that, please, if you can do one thing tonight, take this guided lessons, download that, put that into your emergency lesson plan. This is something that students can work on by themselves. You do not have to be there. There are rubrics to help you grade those lessons that they do. You can put it up in your Google Classroom or whatever platform that you use, and it's there. You don't have to do any writing. It's done for you. So if you do one thing tonight, put that into your emergency lesson plan. Now, you'll notice that we have English and Spanish versions available. This is our teacher resource page, so you can see just how extensive and how many different types of resources that we have. So definitely, I'm not going to be able to go through all of them, but we also have a ready-to-go evolution for elementary school unit as well. Okay, so I can't go through everything, but I'm going to hit some of the ones that I think are just super. Now, we have bell ringers. The bell ringer that I love, and I like to open up my very first day of school with this, to be honest, is this fact or fiction bell ringer. Now, normally what you do is you cut these little pieces out, these little statements out, put them in an envelope. You hand each kid an envelope and a piece of paper that says fact or fiction. So they read these statements, and then while they're reading these statements, you're listening to them. This generates conversation with their table partners, and you're kind of, getting an idea of what their ideas are, what their misconceptions are, what they know, don't know. Gives you a chance to interact and just, sit back and get a feel for what they know. So that was perfect before the pandemic, and now we don't want to have a lot of contact. So I made a game to play to take the place of that. I will give you this icebreaker. This is very annoying music, so forgive me for the annoyingness of the music. Okay, but it's got a column for fact, or it's got a place for fact, it's got a place for fiction. And so you just take the statements like this one here. No one has ever seen evolution happen. Okay, so I'm going to say that's a fact. Humans evolved from monkey. Say that's fiction. Okay, only atheists accept the theory of evolution. Let's say that's fact. Okay, if evolution is disproven, creationism must be true, and so on and so forth. And you just, students can drag and drop these. So now they can do this while they're sitting at their desk, and they're still generating conversation, or they can do it while they're sitting at home and you're teaching, from your computer at home. In the end, they can hit submit answers, and you can have it to where the answers are shown. Okay, so it can show answers. And you're going to see that all of these answers are fiction. I did include 2 facts, and the 2 facts, I believe, it's too small to see right here the way I have it in this presentation, but the cell theory is a theory and the germ theory is a theory. I believe that's what it says. But all of these statements are actually fiction. Now, we're not going to leave you hanging, because in this we have some explanation, so that whether you're talking to students online or you're talking to students in person, we've got explanation for each one of these statements. So you are not left hanging with what to say. All right, and that is a super tool to probe for student conceptions. All right, the next one, I love this particular warm-up that we have, because this is many days worth of bell ringers. Now, in the old days before the pandemic, you'd cut this out and they'd put the vocabulary words, they'd just write them in here. Well, now we have some problems with that because we are not necessarily in person. So I made this other little vocabulary type game. It asks the same questions. And in this little game, it's a balloon pop. Again, the music gets annoying, but a vocabulary word is going to come through here, like, okay, study of the remains of organism from other eras, fossil record. Then they go to the next level and they answer more questions. So that particular activity is all of these just turned into a little game. Okay, and even though it might be a little bit annoying to listen to, it is kind of enjoyable to do for kids. All right, and again, we don't leave you hanging. You've got an answer key here. Now, within this group, we've got different daily evidence evolution handouts that they can do. And in the old day, again, you'd cut this out and hand it to them. They'd answer the questions. Well, what I've done for this one, in order to make it pandemic friendly, is I've turned it into a Google form. And this is just one of the Google forms. So here are some results. You can see that the questions are exactly the same. The students can answer it. And I believe that you should be able to make a copy of this Google form and put it into your lesson, into your Google Drive, and that way you can grade your students' work. I'm happy to send this to you, but unless you make a copy and put it into yours, then I will be getting what everybody has. Now, the great thing about these Google Forms is, like, I had one person here respond, and so the feedback I typed in the feedback, and the feedback is in here somewhere. Oh, that's for the name. There's no feedback for the name. right here. Okay, so right here, the feedback is already there. All you have to do is just release it, and it's going to explain the correct answer if you want them to have that correct answer. All right, so that is one of these that has been turned into a Google form. And then we also have other ones. So this is 20 pages, all kinds of different evidence for evolution. And some of them are digitized. I'm in the process of working on getting the other ones digitized that will be available to you. And I try to use different platforms so that kids aren't getting bored and you're not getting bored by using only Google Forms or whatever. Now, another great thing that I love to do, and this is a very true story. It happened to me, and it happened to Bertha. It's probably happened to you all. It's a bell ringer, and this has been done in the form of generally like when kids are discussing and coming up with ideas, or that activity where you take a placemat and you move the placemat around and kids put their ideas on placemats. But here's the story to it, and the story is going to be provided to you in our website. But this did actually happen. My dog had fleas. I love my dog very much, but I do not like those fleas. So I went to the store and I dropped an easy $100 on everything. I bought a bath for the dog, stuff to spray on the floor, stuff to spray on all of his stuff to spray on him. But it did not get rid of the fleas. I still had it. So before, pre-pandemic, we would generate a discussion. Why in the world could I not get rid of the fleas? Well, now that we have pandemic, I have turned it into a Jamboard. And so those of you who have used Jamboard before know that students can just grab a sticky note and type whatever they want. I think this is what happened. Then you can get around and you can maneuver these things around and group them together. And you can do this in small groups by having 3 or 4 of them work on a Jamboard and check in on them by doing little breakout rooms, or you can do it as a large group, or however you want to do it. Or even I do have students, we're teaching some in person, we're teaching some online right now. So I will use Jamboards in my normal regular classroom. I love the Jamboards. So that's a true story. It's very timely right now that we have the pandemic going on and the whole resistance thing. Here's another activity that comes from the NOVA Embryology Lab, or NOVA Embryology card sort activity. And you may have seen this back before the pandemic. You take this and you cut these little pictures out, put them in an envelope, and then the kids take the pictures and they look at comparative embryology evidence, and they'll try to put them into order according to stages. So like stage 1, what did the fish look like? And then finally, what did the fish end up looking like in stage 3? So again, we don't have our kids, so I had to come up with some good way to put that into an online activity. So I'm using Jamboard again for this one. You share this out, and the kids can say, okay, this looks like it's probably a chicken in its 3rd stage, so I'm going to move it here. This probably a human in the 3rd stage. So this 3rd and final stage, kind of looks pretty easy, but then they get up here to the very beginning, and they start realizing, wow, all of these organisms, it's kind of hard to tell which stage is what. They all kind of look the same, and so they're able to manipulate and sort and see how comparative embryology is a piece of evidence to support evolution. Now, one of the absolute greatest things that we have for you here is this evolution PowerPoint. You can use this in your classroom. You can modify it. You can use pieces of it in your classroom. But the most awesome thing about it is that every slide, almost, has a wonderful resource that it links to. So for example, I'm not going to go through every single one of these videos, but you can click here and go to a super video on the Earth's timeline. Now you'll see that this video, if you haven't seen it, it takes the timeline of the Earth and puts it on a scale of a football field, and he does it with lights at nighttime. And so the students watch this 4.5 minute video, and then at the end they're able to see very effectively and visually just the scale model of life on Earth. So Earth began on this side of the football field, life began here, photosynthetic organisms here, and finally humans we're way down here at the end, right before the stroke of midnight. So this is an awesome video that you have available to watch. Going back to that PowerPoint, there's all kinds of references here that you can get videos about who is Charles Darwin, what was this guy all about. I'm going to take you to this website. If you have not been to this Evolutionary website, you are missing out. So here's another thing you absolutely have to do. Click on that link. It's going to take you to the Evolutionary website. I probably didn't say that right, but this is a life changer. So when you get here, you need to click on this interactive tree of life. So the interactive tree of life, first of all, starts you out right here with this tree of life. Important concept in biology, and we have to teach kids how to read different types of models and how to look at different types of graphs and data. They're going to see these, and they need a little bit of explanation. So I use this not just when I'm talking about evolution, but I use it when I'm talking about phylogeny, when I'm talking about kingdoms, organization, everything. This is useful in all of those things, as I will show you. So they need to see that, it starts here, and the farther away you get, the longer the time has been. So on the outer edges are today's organisms. This also is really helpful because, it shows the different mass extinctions. When we talk about extinctions, we tend to think of just the dinosaurs, or at least the kids do. They don't realize that we've had so many mass extinctions. Opens up dialogue to, the ecological fact that a lot of people feel like we are in a mass extinction right now. So all of this is really cool, but here's the super coolest stuff. If you click on an organism, just pick any organism, it's going to show you a comparison. Like, so for example, for a human compared to a white rhinoceros, we are 21 millionth cousins, 45 million times removed. And it shows you on here the common ancestor between the white rhinoceros and the human, or any organism that you choose. It shows you their kingdom classification information on here. So this website is good in so many different units in your biology class. Definitely you're going to want to keep a hold of that one. Then another big thing that we deal with when we're teaching evolution is that phrase, it's just a theory. What's the big deal? Okay, we have an obligation to students to help them use vocabulary correctly. The media, every television show that they watch, especially all the police shows, will say, well, my theory is such and such. And that is just reinforcing the wrong usage of that word. So here is a super video that talks about what it means to be a theory. And, without going and watching the whole video, you can go here and it explains what is the difference between a theory and a law, a hypothesis. And it points out, that there are other theories, like the theory of gravity. That is a theory. The germ theory. That is a theory. We don't question these things, but they are also theories. So again, super powerful video that is available and linked on that PowerPoint for you to watch. Now, depending on where you need to go, what level you teach, I could stay on this PowerPoint for weeks, literally, because if you need to go deep into fossils, there's a great explanation about fossils, articles, resources, biogeography, resources, law of superposition explains it very well. Um, and there are links embedded everywhere. But because we're, short on time, I'm going to be picky about the links that I go to. And here's the one that I want to show you. It is about the Siberian foxes. Now, this is the best story, and it is in Dogs Decoded. There is a link to this in our website. You can fast forward it to 35 minutes so that you don't have to watch the whole thing. But to give you a real quick story about the Siberian foxes, this, maybe about 40 or 50 years ago, I'm not sure, in Siberia, the foxes were chosen for lack of aggression. And foxes that were not aggressive were bred together. And so after about 40 years or so of doing this, there are domesticated foxes that make these wonderful pets. I don't think that they're, just for sale everywhere. I wish they were, because I would sure buy one. But it talks about artificial selection. And again, students love this, adults love this. This is the best video. And it really drives home artificial selection and opens up that opportunity for talking about, dogs, and how some of the thoughts about how dogs have become our best friends from ancestry with wolves. Vestigial structures. This is a great video about vestigial structures in humans. The kids, of course, are always going to want to know something that is more about them. And so this talks about different vestigial structures that humans have. And as you're going through this video, you're going to see kids wiggling their ears. You're going to see them trying to see that vestigial structure in their wrist, whether they have it or not. Super video that you have available to you. Comparative embryology. Again, we're not going to leave you hanging. We've got answer keys in here with that comparative embryology activity. Molecular biology, linked to Journey into DNA. Then I am really short on time at this point, but I want to point out that we have a link to Dr. Kenneth Miller's explanation of explaining the human chromosome. So if you saw him last night or in his opening remarks, phenomenal speaker, phenomenal video. Richard Dawkins compares humans and chimp DNA. And this one, another one that you absolutely have to go to, the evolution of bacteria on a mega petri dish. So when you click on this one, It is a video. What they did, they took this great big huge petri dish that's like the size of a big table. They put bacteria on the ends, and at different places they put different antibiotics. This bacteria was allowed to grow, and you will see that as it grew, it would hit a certain amount of antibiotic or a certain type of antibiotic, it would die. There would be bacteria that was resistant to it, which would grow. And so you can physically see this happen till it meets in the middle. And then at the very end, they put a phylogenetic tree there. So what I love about this is it's talking about resistance, it's talking about evolution, and it's actually showing them in real time the common ancestry of this bacteria, with this phylogenetic tree. So, again, when they're taking these exams, they need to understand how to look at a phylogenetic tree. Okay, natural selection. There's a lot of misconceptions about what it means to be that phrase, survival of the fittest. So we have of course, an obligation to make kids understand that it is survival of the fittest in a particular environment, not the strongest, not necessarily the fastest, but how fit is something for that particular environment. So I have one other resource that I want to show you that is available, and that is a skull comparison lab. You can go and purchase a skull set that costs a whole lot of money and do a skull comparison lab, but we have a resource here that is on PowerPoint, and you can do a skull comparison lab of even at home virtually or in class, because this is on PowerPoint and they're comparing skulls. So it is a great alternative to that great, that expensive skull set that you can purchase. All right, so getting back to the ending here, and I know I've taken a very long time, but I want you to reach out to me. I want to help you get involved with the organization. We do pay our presenters if you are interested. You can go to the Teachers Institute for Evolutionary Science website and see that there's no way that I even touched on all of the resources that we have. So please feel free to look through those resources, use them for anything you like. My email, again, pattyhowell2001@gmail.com, if I can answer any questions for me. Thank you so much for listening, and have a wonderful evening.